Linux from scratch 11.1 episode 18. Okay, let's start from where we left. In the previous episode, we built the module or package shadow. So let's clear uh, the shadow directory. Okay, now we extract GCC 11.2.0 for the build. .xvf gcc. Okay, the GCC package contains GNU compiler collection, which includes C and C++ compilers. Approximate time is 153 SPU with tests. 4.3 GB is the required disk space. It's quite a big module package. It will take a lot of time. Installation of GCC. At first, fix an issue breaking libason.a. Building this package with glib c 2.3 or later. Sed is a command which is extensively used to modify the files. Probably I will make a video on sed command alone. We have seen the contents of GCC before. Basically contains C++, C compilers, C preprocessor, G++ again it's C++ compiler, GCC is a C compiler, GCC AR is a wraparound AR that adds a plugin to the command line. GCC NM is a wraparound NM that adds a plugin to the command line. Ranlib, a wraparound Ranlib that adds a plugin to command line. Gcov is a coverage testing tool. Gcov dump, offline GCDA and GCN no profile dump tool. Gcov tool is offline GCDA profile processing tool. LTO dump is a tool for dumping object files produced by GCC with LTO enabled. These are all the libraries to support these applications, these programs. Okay, let it extract. Okay, now that we extracted, then GCC. Let's move to GCC folder, then sed command to basically fix an issue with breaking libason.a library. Okay, if building on x86-64, this is our case, change the default directory name of 64-bit libraries to lib. Yes. The GCC documentation recommends using a separate build directory. Okay, let's do build cd to build directory. Now prepare GCC for compilation. Okay, so meaning of the new configuration options LD is LD. This parameter makes the configure script use the LD installed by the binutils built earlier in this chapter rather than the core build version which would otherwise be used. Okay, cross build. Okay, with system zlib, this which tells GCC to link to the system installed copy of the zlib library rather than its own internal copy. Note that for other programming languages, there are some prerequisites that are not yet available. Okay, for instructions on how to build all GCC supported languages. Okay, now we enable language. Now we're building only for C and C++. Now we'll compile it using mic. Okay, now that it started compiling, as you know, it's going to take a lot of time. Let's wait until the build is uh, finished. Now that the build is done, the important thing is in this section, the test suite for GCC is considered important, but it takes a long time. First time builders are encouraged to not skip it. The time to run the tests can be reduced significantly by adding -jx to make the command below uh, where x is the number of cores on your system. So in my system, I allocated 2 cores. So what I will do is I will do J2, or maybe I think it's okay. I will run without the -j. So we will limit one set of tests in the GCC test suite is known to exhaust the default stack. So increase the stack size prior to running the tests. Okay, and see it own or v.tester. Basically, we are owning the tester directory here. Change the ownership to the tester. Then switch user to tester. Cannot drop the control terminal. Okay. To receive a summary of the test suite, run the -await contrib test summary. Okay. Cannot drop the control terminal. Okay, that's fine. Hope it's a valid command. Let's run it. For only the summaries, pipe the output through grep a7 sum. But wait, so it looks cannot drop the controlling terminal. I have an error here. Looks like, well, probably in the interest of time, I will not run this. I don't want to debug this thing. That's fine. I assume that everything is okay. It, 8 tests related to analyze are not to fail. Okay, that's fine. These are related to C plus in libstdc plus was one test named 84745.cc now to fail. Okay, let's not get into tests. Let's install them. Now we will remove the unneeded directory. The GCC build directory is owned by a tester. Now the ownership of the installed header directory and its content will be incorrect. Change the ownership to root user and group. Okay, probably this is not needed because okay, fine. Create a symlink required by fetch for historical reasons. Okay, we're just creating symbolic reasons to adhere to the file hierarchy system. That's standard. Add a compatibility symbolic link to enable programs with link time optimization. Okay, now we have linked. Now that our final toolchain is in place, it is important to again ensure that compiling and linking will work as expected. We will do this by performing some sanity checks. Basically, we are creating a dummy.c file here. Okay, and then we're trying to build this cc dummy.c. Okay, read elf.outlib just to check that if we have proper libraries. Okay, there should be no errors, and the output of the last command will be allowing a program specific differences in the symbolic linker name. Okay, we have the same thing x86. Okay, LD Linux x86 64.so.2. That's fine. Now make sure that we are set up to use the correct start files. Okay, so add success. The output succeeded. The output of the last command should be succeeded. Okay, we have all the succeeded. Depending on your machine architecture, and the above may differ slightly. Difference will be name of the directory after the user libgcc. User libgcc x86 PC Linux GNU. I think that's fine. Okay, I have the same architecture, so it's fine. Verify that the compiler is searching for the correct header files. Okay, this command should return the following output. Include. Okay, fine. Okay, now it's same. Again, the directory named after your target triple may be different than above, depending on your system architecture. Next, verify that the new linker is being used with the correct search paths. Okay, I think. Well, when I was running for this command, uh, somehow my recording did not go well after this command basically. So and now we verified that the new linker is being used with the correct search paths. So I have followed this and then I did not get any errors as such. Probably I can show it here. The grep search. Okay, it's difficult to search the command in the log because it's a lot of log messages. Anyways, okay, so the grep v8. Okay, I think this is this command. Yeah, b4. Yeah, grep b4. So this produced this output, the proper one. This is the output that it produced, and the next is grep search user lib dummy.log. So this command searched for basically the linker is being used with the correct search path, so that also search directory is fine here. Next, the make sure that we are using the correct libc. When I entered the command attempt to open user libgc succeeded. So this is the same message we got. That means it's using the correct libc. Make sure the GCC is using correct dynamic linker. Grep find dummy.log. So here uh, grep found command produced this. It actually found the correct library here. And once everything is working properly, clean up the test files. So I removed the test files test.c out and dummy.log. Finally, move a mismatched file. So we have removed it. Sorry, we have moved it to the user user share GTP, user share GTP, auto load user lib. So these are things, and then appropriately we move to the files. Okay, so now that we finished the GCC, the contents also we have seen in the previous episodes. Now let's move on to package conf, and then we come out. Yes, also, yeah, also we had sources, and then we have to go to, let's extract the tar xvf pkg package conf, and then cd2 package. Okay, the package conf package contains tools for passing the include path and librarian path to build tools during configure and make phase of the of package installations. Okay, this basically used for the configuration of the packages. Now preparing package config for compilation. The meaning is with internal glib. This will allow package config to use its internal version of glib because an external version is not available in LFS. Disable host. This option disables the creation of an undesired hard link to the package config program. Well, it will not take much time for compilation. It's a small module, a package, small package. Okay, now that the configuration is done, let's go for building. I use J4 this time. Let's see if it's faster. And I will not run the tests for this package. The contents of package config contains package config returns meta information for the specified library or package. Okay, now that the package is compiled, let's install. Okay, now move on to end curses. So remove the package pkgconf. Okay, so rm-rf pkg conf. Okay, then extract xvf and curses, then cd to n curses. The ncurses package contains libraries for terminal independent handling of character screens. Okay, let's configure this package with these options. Meaning of the new configuration options. Enable wide C. This switch causes the wide character library example encurses w.so.6.3 to be built instead of the normal ones. Okay, these wide character libraries are usable in both multi-byte and traditional 8-bit locales, while normal libraries work properly. Only 8-bit locales, wide character and normal libraries are source compatible but not library compatible. Okay, that's the reason we generate wide characters. Enable PC files. This generates and installs .pc file for package config without normal. This switch disables building and installing most static libraries. Now the configuration is done. Let's compile this. This package has a tester, but it can only be run after the package has been installed. The test resides in the test directory. See the README file in the directory for further details. The installation of this package will overwrite lib and cursive w so in place. It may crash the shell process which is running code and data from library file. Install the package from destination directory and replace the library file correctly using the install command. A useless static archive which is not handled by the configure is also removed. So we are installing in the pwd destination install. So the present working directory. Well, now it is compiled. Now it's compiled. Let's install it into this directory. Basically, from the destination directory, we are copying things into userlib. Now install it to userlib. Okay, and remove these directories. Okay, copy the destination to the root. Many applications still expect the linker to be able to find the non-wide character in Curses library. Trick such applications into linking with wide character libraries by means of symbolic symlinks and linker scripts. Basically, we're linking to non-wide character uh, in Curse library wherever required. Finally, make sure that all applications that look for encurses at build time are still runnable. Basically, removing the encurses wide from the user lib. Echo input encurses w. Okay, so if desired, install the encurses documentation. Okay, let's install the documentation also. Okay, the instructions about don't create non-wide character encurse libraries against them at them. However, the only non-binary only applications that link against non-classified character libraries are required version 5. If you must have such libraries because of some binary only application or the component with LSB, build the package again with the following commands. Okay, so I will not do this. I will use only the uh, wide character libraries to be used. Okay, no, it's like it looks like against non-wide character and cursor library request. If you must have such libraries because of some library only application or to be compliant with the LSB, build the package against this. So maybe we will use this as well. Well, now that we have installed the uh, not white characters, also, I mean to say, uh, we built the non-white character and curses libraries, and then we install and copy it to the appropriate location. And now we are ready to move to next package. So by then meanwhile, we will come back and then remove the curses package content. Now it is time to again compile the sed extract xvf sed. Then we will this SCD package contains a stream editor. Normally we use SCD to edit files, content of the files. And the let's move to SCD. Oh, 4.8 folder. Then we configure compilation. Contents of SCD is filters and transform text files in a single pass. So basically it's to transform text files. If you want to add anything, if you want to delete something from the test file, so if you want to insert something to the test file, we can use SED set. It will take 0.4 SPU and 31 MB of disk space it requires to build. Oh, not a big module as such. Well, now the compilation is done. Let's uh, sorry, now the configuration is done. Let's compile it. Now we will do make HTML for the documentation. So anyways, I am not going to run the test cases here, tests. So let's straight away move to make install. Also install the documentation. Okay, fine. Now let's move to PSMIC. PS contains display information about running process. PS is a command, as we know. Probably it's related to that. Let's uh, come back and remove the SED module, SED, sorry, package source files, and then let's extract PSMSC, okay, and then CD to PSMSC, and then let's install it. Configure here like this. We just prefix user. The contents of PSMIC are if user kill all peak ft. Okay, let's read the description. If user reports the process ID, PIDs of processes that uses the given files or file systems, kill all kills process by name. It sends signal to all process running any of the given commands. Peak ft, peak are the file descriptors of running process given its PID. PR PRT prints information about process. PS log reports current logs path of the process. PS tree displays running processes tree. PS tree.xll same as PS tree executes that it waits for confirmation before exiting. Okay. Now let's make it. Build it. It says less than 0.1 SBU. It would take small time. Okay, then make install. Okay, now let's compile. Let's move on to the next package. Let's get text. CD, come back, then remove the PS miss, and then extract the get text. So the get text package contains utilities for internalization and localization. These are programs to compile with NSL native language support, enabling them to output message in the user's native language. It's basically to support to uh, their native language. Then it would take around 2.7 SPU, and disk space that it requires is 233 MBs. Let's prepare for the build. Actually, this LFS build is taking more time than I expected. So as my PC is a little slow. But anyways, we will continue. I wanted to finish within 20 episodes, but I don't think so that's going to happen. So it will take more time, more episodes to say. Well, there is some issue while recording. So after GCC, I am facing some issue with my OBS Studio software. So it's okay. I'll fix it after this episode. The thing is that now I had completed the get text build and the installation. Do the uh, I did not run the tests. Now that it is uh, installed, in the next episode, I will start with the Sun. So we have seen the contents of the get text in our previous episode. Please watch that. Okay, that's all for this episode. Mm, Thanks for watching. Please subscribe to this channel. Also leave a comment or feedback in the comment section. Thanks for watching.